So which means that for a transaction to be confirmed, once you do the transaction, the next second, just like what you see in the net banking world, you won't have a transaction confirmation immediately. You'll have to wait minimum 10 minutes. And in most cases, it is preferred that you wait for 5 or 6 blocks to confirm before you tell that your transaction is confirmed. We will come to that also in a little while. So essentially, when we are saying 6 blocks to be confirmed, we are essentially looking at 60 minutes, which is around 1 hour, to tell that my transaction is confirmed forever. Okay. Now we'll come to the roles again. Miner is someone who creates a block. Now full node is someone who has the full details of all the blocks in the network. Okay, full details of all the blocks in the network. SPV is a lighter node. So this is full and this is partial. Just understand the difference. SPV the full form is simple payment verification. So SPV nodes are lighter nodes which actually carry only partial set of details, but it contains details of all blocks, but it contains only partial details. Now, come back once we see the block analysis. Valid transactions, so that is why it first goes to the transaction pool, but those are unconfirmed. Now what does the miner node do? Miner takes at time t1, it is 10 minutes after the previous block, it takes the transaction that is there in its transaction pool. So as of now we have seen that it contains transaction 1, transaction 2, transaction 3 and transaction 4. Now it orders the transaction according to its timestamp, and here comes the application of the Merkle rule. So here we have t1, t2, t3, t4. Previously we saw in Merkle rule to store these transactions, start hashing these leaves, which becomes the leaf node in the Merkle tree, and we pair up these hashes and form the next level hashes, which is x1, 2, x3, 4, and we pair again to form x1, 2, 3, 4. Right? So this is where I told you before that Merkle tree gets applied in the network. This is where Merkle tree finds its application. Now let's take a block B4 of a node N3. Now you have to understand that, assume that B4 is the block in which transaction 1 has gone in, which is this transaction. Similarly, there is transaction 2, transaction 3, transaction 4, which is between different participants in the network. Okay, and assume that B5 is the new block which is under creation by a node N6. Now at time T1, N3 will have B1, B2, B3 and B4. Similarly, N4 will have the block chain consisting of 4 blocks. So you have to understand that this blockchain, which is the ledger or the fabric, it exists across all the nodes. Okay, so it is not one single blockchain across the network, but it is a fabric or a distributed ledger. That ledger exists across all these nodes. So there are 4 blocks here as well. Now whenever we have seen that N6 is a miner who creates blocks. Whenever N6 creates a block, that block gets populated or flooded across the network, and then B5 will get added here. We will see that in a while. T1, the node N6, which is the miner who is supposed to create the block, sees its transaction pool, and it understands that I have transaction 1, transaction 2 and up to transaction 4, which are not yet confirmed but with the valid transaction. So it actually starts the process of mining, which actually creates a block. So essentially we saw that we have 4 blocks in the network. We are trying to create the 5th block in the network. Now let's see how block 5 will look like. Okay, so we have block 1, block 2, block 3, block 4. Now what will happen is block 5 is about to get proposed. Okay, now I am going to explain block 5 here. Okay, so block 5, each block it has a header. So let's assume this is the header and it has a body. Okay, so this is an enlarged view of block 5 that I am showing. Now the body will contain nothing but transactions. So here it is transaction 1 to 4. 1, 2, 3 and 4. Now this will form a Merkle root by combining transactions 1, 2, 3, 4. This is equivalent of this that I am drawing here. Okay, and this finally forms H1, 2, 3, 4, which is nothing but the Merkle root we have seen before. Okay, so now all these transactions listed here, transaction contains nothing but its timestamp also. Now the Merkle root from all these transactions, it gets written here in the header. So essentially, instead of bringing all the transactions into the header to make the header little light in terms of the data it is containing, it just writes a Merkle root which essentially represents all the transactions which are part of the tree, right? Which we have seen earlier, what is Merkle root and what is its usage. Okay, then what does the header contain? It will also have the timestamp at which this block is getting written. So timestamp. Some cases or some blockchain networks have the number of transactions. So in this case, it will write it as 4. Okay, then it will have something called as nonce. Okay, now I am coming to what is nonce in a while. Okay, now this is the block structure. This is what block 5 is going to be.